Hello everyone, welcome to Natus and Aptitude World. This is the fifth set of quantitative aptitude questions. The topic is LCM and HCF. 41st question. Already we discussed 40 different models in previous videos. Just to go through and check the questions. Now, this one. There are 576 boys and 448 girls in a school that are to be divided into equal sections of either boys or girls alone. Either boys or girls alone. Find the minimum total number of sections. Suppose the number of sections are less. What about the number of students in each and every section? That is equal to more or not. Next, either boys or girls alone must be equal. Boys and girls must be equal. And what we require, minimum section, each and every section contains maximum number of boys as well as maximum number of girls. That too, though that number must be a factor of these two numbers or not. Here we will find out the HCF of these two numbers. Just look after this one, 576 and 448. See, now what is the HCF of these numbers? And let us divide this number with 2. This is 2, 8, 8, and this is 2, 2, 4. Again divide this number with 2. This is equal to 144. This is equal to 112. And again divide with 2. This is equal to 76, 72, and this is equal to 56. Again divide with 2. This is 36 and this is 28. Again divide this number with 2. This is equal to 18 and this is equal to 14. Now again divide this number with 2. This is equal to 9 and this is equal to 7. See, what is the HCF? All of you listen carefully. What is the HCF? That is 2 into 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5, 6. 2 to the power of 6. What is the 2 to the power of 6? That is equal to 64 or not. Now, each and every section have 64 numbers. Now, what we require, total how many sections are required to place these 576 boys? What can we do? We will divide this 576 with 64 or not. If you divide this 576 with 64, what will you get? That is equal to 9 only. And if you will divide this 448 with 64, then what you will get? That is equal to 7 or not. No need to find out HCF, and that is nothing but you will multiply all these numbers and again divide this number with 64. Just you will add the last two numbers, that is 9 plus 7, that is equal to 16 is the required answer. Is it clear? No need to multiply all these numbers and again divide this number with all these numbers, right? Just you will simply add last two numbers. 9 plus 7 is equal to 16 is the required answer. Find the LCM of 16 minus x square and x square plus x minus 6. Here quadratic equations are there. Now what we require here, 16 minus x square, and the second one is x square plus x minus 6. Now you will, what we require LCM? First you will convert factors, product of the factors, right? This is equal to 4 square minus x square or not. So this is equal to 4 minus x into 4 plus x, right? Now convert this equation into factors, that is equal to x square plus x minus 6. 6 into 1, that equals minus 6 or not. So what can we do? This is x square plus 3x minus 2x minus 6. So x into x plus 3 minus 2 into x plus 3. So what are the factors? This is equal to x minus 2 into x plus 3 or not. Now what we require? Here we required the LCM, that is all our individual factors. So we will take a product of all these numbers or not. So 4 minus x into 4 plus x into x minus 2 into x plus 3. Here x minus 3, this is not correct, and this is also not correct, this is also not correct. What is the answer? Answer is option D. Answer is none of these. Our answer must be 16 minus x square into x minus 2 into x plus 3. This is also equal. Or one more thing is there, and that is equal to 4 minus x, this is not x square. Suppose this is x square is there, then x minus 2 into x plus 2 is also possible. So that is also not required, not possible. So what is the answer? Answer is 16 minus x square into x minus 2 into x plus 3. None of these is the correct one. Next one, find the HCF of x square minus 4, x square plus x minus 6. Find the HCF of quadratic equations. Here the equations are x square minus 4 and this is x square plus x minus 6. And what about this one? This is x plus 2 into x minus 2 or not? X plus 2 into x minus 2. Now this one is x square minus plus 3x minus 2x minus 6. So x into x plus 3 minus 2 into x plus 3. So x minus 2 into x plus 3 or not? X minus 2 into x plus 3. Now what is the HCF? HCF is nothing but a common factor of these two numbers or not? What is the common factor of these two numbers? X minus 2 is the common factor of these two numbers. So what is the answer? Option B is the correct answer. 44th. Find the GCD, greatest common divisor. Either GCD or HCF, both are same. Find the GCD of polynomials x plus 3 whole square into x minus 2 into x plus 1 whole square and x plus 1 whole cube into x plus 3 into x plus 4. Now, suppose if you take x plus 3 whole square, here x plus 3 is there. What is the common factor of these two? You all of you remember, here you will take a common basis. What is the common base? X plus 3 is a common base. This is the first one. And x minus 2 is there. Here x minus 2 is not there. X plus 1 is there. So x plus 1 is a common base of these two numbers. Now what we require? HCF or GCD. Suppose in HCF or GCD, here you will take common basis but least power. What is the least power of x plus 3? This is 2 and this is 1 only. So what is the answer? X plus 3 whole to the power of 1. And next, what is the power of x plus 1? This is equal to 2 and this is 3. What is the smallest number? 2 or not? So x plus 1 whole square. And here x plus 4 is there. Here x plus 4 is not there. So what is the answer? X plus 3 into x plus 1 whole square. Option C is the correct answer. 45th one. The LCM of x plus 3 into x6 x square plus 5x plus 4, 2x square plus 7x plus 3 into x plus 3. Now, the equations are x plus 3 into 6x square plus 5x plus 4. And whatever the other one, 2x square plus 7x plus 3 into x plus 3, right? Now x plus 3, this is 24, but what is the middle number? 5. It's not possible, exact factors. Now this one, 6, 3 into 2, 6. So this is 2x square plus 6x plus x plus 3, right? So 2x as common, this is x plus 3 and plus 1 is common, x plus 3. So what happened? This is 2x plus 1 into x plus 3. Right? So what is the 2x square plus 7x plus 3 into x plus 3? That is equal to 2x plus 1 into x plus 3 into x plus 3. Now what we require? We require LCM. LCM is nothing but you will take all the bases or not. What about the base? That is equal to x plus 3 into 6x square plus 5x plus 4 into 2x plus 1, right? And here x plus 3 whole square, here x plus 3. So what happened? X plus 3 whole square. What is the answer? 2x plus 1 into x plus 3 into 6x square. If you observe this one, in these three options, except this option, the remaining three options, 6x square plus 5x plus 4 is not exist. But What about this one? 6x square plus 5x plus 4 is there, and x plus 3 also there, but x plus 1 by 2. So if you observe, this is x plus 3 whole square into 6x square plus 5x plus 4 into, suppose if you will take 2 as a common, what happened? X plus 1 by 2 or not. If you observe, this is equal to 2 into x plus 3 whole square, 6x square plus 5x plus 4 into x plus 1 by 2. What is the answer? Option C is the correct answer. 46th, find the two natural numbers whose difference is 66 and the LCM is 360. And the LCM is 360. See, these type of questions are better to go through the options. The difference is 66. Here the difference is 120 minus 54, 66. 90 minus 24, 66. 180 minus 114, 66. 130 and about 30, 64, that is also 66. But what we require, the LCM is equal to 360. So better to apply the factors. Just if you thorough with tables is very simple, otherwise bit difficult. I said this is equal to 120 and this is equal to 120, and what happened? 54, 3 into 18. So 18 is not a factor of this one, right? And 3 into 1 is 360. What happened? That is a factor. And if you observe the all factors and you will find out the LCM of these numbers, then you will find out the exact answer, right? Suppose if you go through LCM of all these numbers, option B satisfy the condition. 47. Find the HCF of 2 to the power of 100 minus 1 and 2 to the power of 120 minus 1 is. All of you remember one formula. Here, the HCF of a power x minus 1 into a power y minus 1 is. The HCF of a power x minus 1 comma a power y minus 1. That is a to the power of HCF of x comma y minus 1 is the answer, right? You must remember this formula. The HCF of a power x minus 1, a power y minus 1 is a power HCF of xy minus 1. Here, suppose if you go to this one, 2 a is 2 and x equal to 100 and y equal to 120, right? So what is the answer? 2 to the power of HCF of 100 and 120 minus 1. So 2 to the power of 20 minus 1 is the answer. Option A is the correct one. Find the HCF of 2n plus 13 and n plus 7. See, suppose this is the quadratic equation, then you will find out the factors of these numbers. But these two are not a quadratic equation. Now, what can we do? Just you will take a trial and error process. If n equal to 1, that implies 2n plus 13 is equal to how much? 15, right? And next, n plus 7 is equal to how much? That is equal to 8. Now, these two are co-primes or not? So, what is the HCF of co-primes? That is equal to 1. HCF of 15 and 8, that is equal to 1. You will take any number and take a trial and error process, you will get the answer. Option D is the correct answer. LCM of two natural numbers is P and Q, where P is greater than Q is 935. Here, two natural numbers, that is P and Q, where P is greater than Q and LCM of two numbers equal to 935. What is the maximum possible sum? This is very important. The maximum possible sum of digits of Q. That's what we require. See, and what is the number? 935 or not? First, you will convert this number into product of the prime factors, right? So 935 is equal to 5 into 11 into 17. Here three numbers, product of three numbers are there, right? And next, what we require here, LCM of two natural numbers. Suppose one number is p and the number is q. What is the other number? Let us take x. Let us take that is equal to x. Now, here let p is equal to hx and q is equal to hy. What is the LCM? LCM of LCM of p and q, that is equal to h, x, y or not. That is a product of three numbers, right? Now, if h equal to 5, and what about the p and q? We will take the regarding 11 or 17, whatever it is. But you must observe p is greater than q. That must be observed. Now, you will take a trial and error process. Suppose if h is equal to 1, then what happened? If h equal to 1, p and q, the product of p and q must be 935 or not. And p is greater than q, so that means p is equal to 935 and q is equal to 1 or not. P is equal to 935 and q is equal to 1. Now, what is the sum of these two digits? Sum of is equal to 1 only. Only one digit is there. Next, if h is equal to 5, here 5 into 11 into 17, that implies what is the p? P must be greater than q. Right? So p must be 17 and q must be 11. So hx, so 17 into 5. But what is the q? That is equal to 11 into 5. That implies q is equal to 55. What we require? The sum of the digits. So this is equal to 10. Next, if h is equal to 11, then what is the value of p? That is equal to 17 into 11. That equals 17 into 11. And what is the q? That is equal to 5 into 11. Right? So that implies q is equal to 55. What is the sum? Sum is equal to 5 plus 5. That is equal to 10. If h is equal to 17, then what is the value of p? P must be 11 or not. So this is equal to 17 into 11. And what is the q? Q is equal to 11 into 5, right? So 17 into 5. So this is equal to q equal to 85. What is the sum? 8 plus 5, that is equal to 13. Suppose h equal to 1, the sum is equal to 1. Suppose h equal to 1, that sum is equal to 1. Suppose h equal to 5, that sum equal to 10. Suppose h equal to 11, that sum equal to 10. If h equal to 17, what is the sum? 13. What we require? Maximum possible sum. So what is the answer? Option D is the correct answer. Next one. The HCF and LCM of two numbers are 21 and 4641 respectively. If one of the number is between 200 and 300, the two numbers are. Now, here product of two numbers A into B is equal to product of their LCM and HCF or not. That is 21 into 4641. Now what we require? We require A and B. And one condition is also there. What is that condition? One number is lying between 200 and 300. Right? First you will convert these numbers into product of the prime factors. Why? Because this is already two-digit number. Right? So 4, 6, 4, 1. Divide this up 4, 4, 8, 14, 15. So divide this number with 3. 1, 5, 4, 7. Now divide this number with 7. This is equal to 2, 2, 1. So what happened? So this is equal to 21 into 221. One number is lying between 200 and 300. And so what is the answer? 221 into 441. But you must observe what is the HCF of these two numbers, that is equal to 21. What is the meaning of the statement? Here 21 is a factor of those two numbers or not. Here 21 is a factor of 441, but 21 is not a factor of 221. So option A is not correct. Be careful. Right? Now what can we do? Now you will convert. If you are thorough with the tables, then it is very simple. Otherwise, bit difficult, right? So 13 17s are 221. 13 17s are 221. So this is equal to 21 into 21 into 13 into 17. Right? Now what we require, 21 must be a factor. Now what can we do? You will take 21 and 13 as a one number. 21 into 17, that is another number. 13 20s are 260 plus 13 273. 17 20s are 340 plus 3 go 357. One number is lying between 200 and 300 and two numbers are there, and 21 is a factor of these two numbers also. So what is the answer? Option B is the correct answer. That's all for today. That's all for this video. Stay tuned to my channel. I always upload different concepts and different examples, and each and every model, if you go through those all models, it's very easy to crack any competitive exam. Thank you, one and all.